Download this code from codegive.com, link in the description below. Java's bufferedreader.lines, method explained, a comprehensive guide. The buffered reader class in Java is a fundamental component for efficient reading of character input streams. It provides buffering, which significantly improves the performance of reading data compared to reading directly from inputstreamreader or similar character streams. One of the most convenient methods introduced in Java 8 is the lines method, which transforms the buffered reader into a stream of strings, each representing a line of text. This tutorial will delve deep into the lines method, explaining its purpose, usage, potential caveats, and providing illustrative code examples. 1. What is buffered reader and why do we need it? Before diving into lines, let's briefly revisit buffered reader. It's designed to enhance the performance of character input operations. Without buffering, each read operation, example reading a character or a line, involves direct interaction with the underlying input stream, like a file or network connection. This can be slow, especially for numerous small read requests. Buffered reader mitigates this by buffering it reads a larger chunk of data into an internal buffer. Subsequent read operations can then be served from this buffer, avoiding repeated accesses to the underlying stream. Line-oriented reading provides methods like readLine, that efficiently reads lines of text. 2. Introducing bufferedreader.lines. The lines method, available from Java 8 onwards, offers a streamlined way to process lines of text from a buffered reader. Instead of repeatedly calling readLine in a loop, you can directly obtain a stream string representing the lines of the input. Signature returns a stream string where each element is a line of text read from the buffered reader. Behavior it reads all lines from the buffered reader until the end of the stream is reached. The stream will not contain the line termination characters, like \n or \r\n. Exceptions unchecked I/O exception, if an I/O error occurs while reading from the underlying input stream. This is an unchecked exception, meaning the compiler won't force you to catch it explicitly, but you need to handle it gracefully nonetheless, example with try-catch blocks. 3. Benefits of using lines, conciseness reduces boilerplate code compared to the traditional read line loop. Readability makes your code easier to understand. Functional programming enables easy integration with other stream operations for filtering, mapping, and processing the lines of text. Parallel processing, potentially while not always necessary or beneficial, stream operations can be easily parallelized, using parallel, if you have a performance-critical need to process lines concurrently. 4. Basic usage with code examples. Let's demonstrate how to use lines, with different examples. Example 1, reading from a file and printing to the console. Explanation *. 1. Import java.io and import java.utilitystream.stream, **** import necessary classes for file I/O and streams. 2. File path equals example.txt, * defines the path to the file you want to read. Make sure to create a file named example.txt in the same directory as your Java program, or provide the full path to the file. 3. Try, buffered reader equals, * uses a try with resources block to ensure that the buffered reader is automatically closed after use, even if exceptions occur. This is crucial for preventing resource leaks. 4. New buffered reader, new file reader, file path, * creates a buffered reader wrapping a file reader, which connects to the specified file. 5 stream string lines equals reader.lines, asterisk calls the lines method to obtain a stream of strings, where each string is a line from the file. 6 lines. For each, system.out.println, asterisk iterates over the stream of lines and prints each line to the console using a method reference system.out.println. This is equivalent to lines. For each, line-system.out.println, line. 7 catch, IO exception E, asterisk catches any IO exception that might occur during file reading. Example 2, filtering lines based on a condition. Explanation asterisk. Asterisk this example builds upon the previous one by adding a filter. Asterisk lines.filter, line-line. Contains, keyword, asterisk filters the stream to only include lines that contain the substring keyword. You can replace keyword with any condition you want to use to filter the lines. Example 3, transforming lines and collecting to a list. Explanation asterisk. Asterisk this example shows how to transform the lines before processing them. Asterisk lines.map, string to uppercase, asterisk transforms each line in the stream to its uppercase equivalent using the map operation and a method reference to the to uppercase method of the string class. Asterisk .collect, collectors.toList, asterisk collects the transformed lines into a list for further processing or storage. Collectors.toList is a collector that accumulates the elements of the stream into a new list. Example 4, parallel processing, use with caution. Important considerations for parallel processing asterisk. Asterisk overhead asterisk parallel processing introduces overhead due to the splitting of the data, thread management, and combining the results. For small files or simple operations, the overhead might outweigh the benefits. Asterisk statefulness asterisk avoid using stateful lambda expressions in parallel streams. Stateful lambda expressions rely on mutable shared state, which can lead to race conditions and incorrect results in a parallel environment. Asterisk ordering asterisk parallel processing can change the order in which elements are processed. If order is important, you should not use parallel. If you need a parallel stream but require the results to be in order, use parallel, along with bufferedreader. However, this often diminishes the performance benefits of parallel processing. Asterisk IO-bound asterisk lines, is inherently IO-bound. While parallel streams might help, the underlying disk IO remains a bottleneck. Consider asynchronous IO techniques for maximum performance. Asterisk file size asterisk parallel processing is most effective for large files where the processing time is significant compared to the overhead of setting up the parallel stream. 5. Potential issues and best practices. Asterisk resource management asterisk always use a try with resources block to ensure that the buffered reader is closed properly, even if exceptions occur. Failing to close the reader can lead to resource leaks and file locking issues. Asterisk unchecked IO exception asterisk remember that lines can throw unchecked IO exception if an IO error occurs during the reading process. You should handle this gracefully. The try with resources block helps, but if you're doing complex stream operations, unexpected IO errors might still happen. Asterisk memory usage asterisk when processing very large files, be mindful of memory usage. Reading the entire file into memory, example by collecting all lines into a list, can lead to out-of-memory error. If you're dealing with extremely large files, consider processing the stream in chunks or using other memory-efficient techniques. For instance, processing and writing data in smaller batches instead of storing everything in memory at once. Asterisk line separators asterisk lines, automatically removes the line separators, \n, \r\n. Be aware of this if your processing depends on the presence of line separators. Asterisk character encoding. Asterisk ensure that you specify the correct character encoding when creating the file reader. Example: new file reader, file path, standard charsets.utf_8, if the file uses an encoding other than the platform's default. Incorrect encoding can lead to garbled characters. Asterisk modifying the file concurrently. Asterisk avoid modifying the underlying file while the stream is being processed. Doing so can lead to unpredictable behavior and data corruption. 6. Alternatives to lines. While lines is very convenient, other approaches exist for reading lines from a file, depending on the specific requirements. Asterisk bufferedreader.readline, traditional approach. This is the classic approach and is still perfectly valid, especially if you are not using Java 8 or later. It's more verbose than lines, but gives you direct control over the reading loop. Asterisk files.lines, path, asterisk. Files.lines provides a simpler way to read lines from a file directly, without needing to create a buffered reader explicitly. It is part of the java.neo.file package. It also handles resource management automatically, returns a stream that automatically closes the file when the stream is closed. You can also specify the character encoding, files.lines, path, standard charsets.utf_8. 7. Conclusion. The bufferedreader.lines method offers a powerful and concise way to process lines of text from a buffered reader. Its integration with Java streams enables functional programming techniques and efficient data processing. By understanding its benefits, potential pitfalls, and alternatives, you can effectively leverage lines to improve the readability and maintainability of your Java code while handling file input efficiently. Remember to prioritize resource management, error handling, and appropriate character encoding when using this method. Always consider the potential overhead of parallel processing and whether it's truly beneficial for your specific use case.